Hello, everyone. Welcome back.
Good afternoon, Ernesto.
Good afternoon.
Good afternoon, Ernesto, and everyone.
Good. So we have everyone in already. So nice. Before we start, so I don't know if you have any questions, comments, or anything regarding our yesterday's session. Okay.
No, I'm good.
Okay. So I apologize. I was able to send the link with the recording of yesterday's session just this morning. And okay, let's continue. We are recording this one, and also you're going to get the recording at the end of the day. So we're going to start now with the next lab, which is a series of activities regarding adding security layers to our Ingate. And the first thing we are going to do is we are going to secure the connection of all the remote users. And in order to do that, we're going to add TLS transport protocol, and we are going also to add encryption for the media. That is what we call TLS SRTP. Then we are going to learn a new section inside the configuration interface that is called IDS IPS, and which is IDS IPS stands for Intrusion Detection System, Intrusion Prevention System. And then we're going to talk about SIP filters, which we already presented in a couple of days ago. But we're going to see it more in detail. Access control list, which is sort of the same, and then a special feature we have for blocking what is called brute force registrar or brute force authentication. Okay, so let's move on. Okay, I don't know how familiar are you with TLS or SSL protocols or SSL-based protocols. But I usually like to explain at least the basic concepts for us to understand what does it mean when you add TLS or either any SSL based protocol like HTTPS, for instance. Adding security using SSL or secure SSL is well, session secure layer in any way. Is a way when you have two entities that they want to establish a session between them. The first thing they should do in order to establish a secure connection is to establish a trust, is be able to trust each other. And once they trust each other, then they can negotiate some way of encrypting the information for them only to be able to interchange data or information. It's like and understanding what means to establish a trusted relationship is important, because that's how you are going to understand how an SSL or TLS session works. So the first thing we need to understand or to learn is what is a TLS certificate, what is an or SSL certificate. What is a certificate? And a certificate is usually a way to identify yourself. When you have a certificate, you are identifying yourself with that certificate. For instance, let's say that you are driving in a highway at very high speed, and a cab stops you. Okay, and usually, what is the first thing the cab asks you to do? Is show me your ID and registration and all this stuff. But basically, the first thing he asks for is, I need to know who you are. Okay, so let's say, for instance, that instead of showing your driver's license, okay, you show, I don't know, a work ID of a company called Acme, uh, with a picture of you, your name, and something like looks like you. So why the CAP most likely will not trust that ID? He's going to ask for your driver's license, okay? Because to establish the trust between the two people or the two entities that are trying to establish a connection to each other is for the side that is asking for the identification is to trust the entity who signed the identification document. In other words, when you show your driver's license, the CAP is gonna trust what the driver's license says about you, your name, uh, whatever additional information, your address, etc. Is gonna trust that because he trusts not you, he trusts the MVA or whoever signed the certificate. So uh, this takes us on a new concept or element in any SSL session, which is trusting on the entity who signed the certificate. And then you're going to start listening about a trusted certificate, a trust entity, a trust CA. That's the name that you usually will hear about. So any certificate is a bunch of identification information and that has been certified by a third party that everybody trusts. Okay, so and that's why there is a bunch of entities that are known as trusted authorities that everybody trusts, like GoDaddy or RSA or VeriSign, or I don't know. There are many entities that are generally globally trusted. And if the certificate is signed by one of those entities, you say this is a trust certificate. Okay, that doesn't mean that you cannot sign a certificate yourself. And that is what is known as a self-signed certificate. And for certain purposes, using a self-signed certificate may be a viable solution. For instance, when you are just trying to trust entities that belongs all of them to the same owner, let's say the phones, the PBX, and everything, and they need to trust to each other to establish SSL or TLS sessions. You can have a self-signed certificate, and the entity that is signing the certificate is the same company. It's the same way you have an ID from the company you work for. So if you have a Forerunner ID and you go to a Forerunner building, um, the security guy at the door is gonna trust the certificate because it was signed by the same company that you are working for and you are trying to enter in one of the buildings. Okay, so for the purpose of this training, we are going to create a certificate for the Ingate, and it's going to be a self-signed certificate just for the purpose of the training. In real life, usually, if the entity you are trying to um, um, enable to establish SSL connections, most likely you want to buy or you want to pay for the signature of that certificate by a trusted authority. Okay, so I'm going to show that in the live system, but let me go through the slides first. So there is a section where you are able to create certificates or load certificates in the Ingate configuration. And we're going to fill the form to create a self-signed certificate. There is a bunch of data that you need to add, like what is going to be the expiration time for the certificate you are creating. Okay, for instance, if I put 36,000 something, 3600 something. It's about 10 years, but you can put any expiration time for the certificate. So there is a country code like US for the United States. Organization could be the name of the company. The example I'm showing is Ingate. The state, the organization unit. All of those fields are basically informational data. My email, the city. The only field that is important in terms of certificate validation, besides who signed it, is what is called the common name, or the CN. The common name must match usually the entity IP address or URL or FQDN of the entity that is going to hold the host the certificate. In our case, for the exercise, our CN is going to be the domain names you have for each one of your teams. For instance, team number 2 is going to be go2siparator.ingalabs.com. Okay, so that's the only field that is mandatory to comply with certain standards. Because when the transaction between two entities trying to establish a trust connection, every time one of the entities shows the certificate to the other one will validate most likely 3 things. It's going to validate if the CN matches with your IP address, or at least the domain name you are holding. The second thing is going to check for the expiration to see if the certificate is still valid. Okay, and the third thing is going to check is the who signed it. Is this certificate has been signed by a certification authority that I trust? Those are the 3 things that will be checked. So in this page, in this form that we are going to use to create a certificate, at the bottom, there are 2 options for the certificate creation. One option is called the create a self-signed certificate, and the second option is to create a certificate request. Okay, for the intention of the training, we're going to just create a self-signed certificate. It's going to be self-signed. But in the real life, if you want the certificate you are just creating to be signed by a third party, a trusted authority, you have to click on the second button to create a request. And that is going to create a file that you have to use that file when you go to the certification authority and provide that file for them to sign. And once they sign the file, is everything, I mean, everything is happening electronically. Once they electronically sign the file, they're going to provide you a result file with the certificate already signed. And then you're going to be able to load it on the Ingate or whatever device you are trying to enable SSL. Okay. So we're going to see also on the certificate section that is located at the basic configuration tag, and under basic configuration tag is going to be a tag that is called certificates. You're going to see on that section that you have 2 different areas. One is called private certificates, and the other one is called certification authority certificates. The certificate we're creating is a private certificate that is going to be used, has the identification of the SBC when the SBC is trying to establish a trust connection with another entity. Okay. So once you have the certificate created, then we can go back to one of the sessions we already did yesterday, which is on the SIP services, just next to the basic configuration. There's a signaling encryption tag. A signaling encryption tag is actually disabled. You're going to need to enable that one, and then on the section that is called TLS connection on different IP address, you're going to need to add a line to select the outside interface and associate the new certificate you just created to that interface. Meaning that on the outside, whenever an SSL or TLS connection is needed to be established, this is the certificate that I'm going to use. Okay, so I'll go more in detail with the live system. And also on the SIP services basics tag, you are going, remember that we left the 5061 port with TLS disabled. So we're going to need to enable that. So once you have that enabled and you have selected the configuration for signaling encryption tag, and you're going to be almost ready to start testing TLS connections. So we're going to do this in 2 steps. Step number 1 is going to be just enable TLS. And once we have TLS working, then we're going to move to enable SRTP, which is media encryption. So let me go to the live system. Any question?
No, I'm good.
Okay. So this is the live system that I'm using for the training. Then we go to basic. Under basic configuration, you're going to see, let me just make it a little bit bigger for everybody to be able to read correctly. Okay, so basic configuration, there is a section called certificates. Then I'm going to certificates, okay? I already have the TLS certificate created, but I'm gonna just delete it and create it again. Let me just delete this one. I'm gonna remove that one. Okay, no, let me just go to basic configuration certificates, okay. The only certificate you are going to see there right now is under private certificate, one that is called HTTPS config, which is the one that comes built in on the Ingate to be able to use HTTPS connection for the interface, for the GUI. Okay, that is already built in. So we are going to need, we are not going to use this certificate for TLS. We are going to use a new certificate, totally different, a new one. So in order to create a certificate, you need just to add a new row, assign a name. Let's call it TLS, just to give it a name. But you can give it any name you want. And then once you have assigned a name, you just click on Create New. And once you create new, the form that I was talking about just shows up. Okay. In my case, it's just filling with the information of the last time I create a certificate. In your case, maybe it's empty or have any other information. So I can decide how many days is going to the certificate last. Let's say that it's going to be 3649, but you can put any number you want there, how many days this certificate is going to be valid. The US country is going to be US. Organization could be, in my case, I put Ingate. You can put whatever you want, or Forerunner, for instance. Florida, which is where I'm located. Sales is my department, organization. This is my personal email, and the city where I'm located. And here on the common name, okay, you see those 2 fields has an asterisk, meaning that those are mandatory. So I use my domain name. In my case, it's 99 is my team number, G99SIParator.ingatelabs.com. You can add additional information. This is an alternative set of values. If I want to have more than one email address, I can put a second email address here. I can put a common name here, a second DNS name here, or a second IP address here. We're going to leave it blank for the training. Then you can select, we're going to leave everything else in by default, but you can select what is going to be the key length in bits. The longer in bits is the length, the more secure the certificate is going to be. But 2048 is basically supported by any other party. but not always 8,000 bits is supported by other parties when you are interchanging certificates. The signature algorithm, the default is SHA-256, but you can select any other one. And you can assign a serial number. If you don't assign a serial number, the Ingate will automatically number every time you create a certificate with a number, a unique number, increasing by one the previous one. So you can also assign a password to the certificate. If you are going to send the certificate to a certification authority to be signed, you can assign a password and then provide the password to the certification authority for them to be able to open the file. Okay, we are not going to use this because we are not creating a request. So we're going to just create the self-signed certificate clicking here. If you click here on certificate request, it's going to create a file that you're going to send, you're going to need to send to the certification authority. So I'm going to click here on self-signed certificate. And once I click here, the certificate is created. This is all the information associated to the certificate, and it's populated here. Okay. At this point, we have a TLS certificate already created. And now I can continue to the SIP services. Okay. And then under basic service, I can enable, it was, in your case, it's going to be disabled. I can just enable the second line of the SIP signaling to explicitly say, I'm going to use port 5061 for TLS protocol. Okay. I'm going to intercept that traffic, and you can put any comment here. Okay, so once you do that, you can go to the signaling encryption. Usually it's going to be like this, disable. You are then able to enable, and then you're going to need to add a line here and select your outside interface, which is the ETH0, and select the certificate you want to use. I'm not going to use the HTTPS. I'm going to use the brand new that I just created. Okay, and here you can enable or not. You're gonna leave it no, but if you enable yes, means that you want to validate that any other certificate that you receive on this interface will be matched against the IP address they are showing. Okay. And also here is that when you send your certificate, you're trying to establish let's say a session between the Ingate and the remote phone. If you select yes here, means that the Ingate will send his certificate to the other party, but it's also going to request to the other party to show his. Okay, so you're gonna say, Mr. Phone, here is my ID, but I also want for you to show me yours. It's like this is not happening on real life, but if the cab that stops you at the highway at high speed asks you for your driver's license, you say, yes, Mr. Officer, here is my ID, my driver's license. Can you show me your identification? Well, you have the right to ask. That's the reality.
So let me just stop there for a moment. I'm actually not getting a TLS certificate. It's not showing me anything.
You are not showing anything?
I
Okay.
think I fell behind you a little bit here.
Okay. Let me stop sharing. And then can you show me?
Yes.
What are you saying? Mm-hmm. Okay.
Right here, I don't have a TLS option.
Can you hear me?
I hear you.
Okay. So let me see why
I don't have a TLS option right here.
yeah, you don't have it because, let me show you why. So you came to, let me ask for request for control.
Sure.
Okay, and this is gonna happen to everyone. Okay, you were originally here in basic configuration and you created the certificate, right? No certificate exists. Okay, you have not created the certificate yet. So you assign a name, okay? And then you have to create the certificate.
I populated the info.
Okay, so here
Oh,
it should
just
be,
the sheet. Gotcha.
okay? GOY 8, blah, 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 Ed Perkins, etc. And then now I'm going to create the self-signed certificate.
So
Now the
this
certificate has,
HTTPS was it? Okay, I see.
that has been created. Now the certificate is here. Now, if you go to SIP services and signaling encryption,
Now it'll be there.
then now it should show here.
Gotcha.
Okay?
Okay, thank you.
Okie dokie. Just stop here. Okay, and let me just go back to my sharing. I'm going to share. Okay, I think I already sharing, right? Yes. Okay, so you're gonna need to, you're gonna keep this in no and this in no also. And also here is a pull down menu where you can select which specific version or protocol of version of TLS are you going to use. The most generic one is this one, the last one, TLS version 1.x and SSL version 3. I usually select that one because it's the one that has more coverage with all the standards. You know, you may have the case where the carrier says, yes, we support TLS. We can do the SIP trunking using TLS, but we only support TLS version 1.0 and 1.1. We don't support 1.2. We don't support version 3. Then you can select here 1.x, for instance. Okay. So this is the the option we are going to use for the training. As you can see, then we are saying specifically that on interface 0, which is my external interface, if I need to establish an SSL connection, a TLS connection, this is the certificate that I'm going to use. I'm not going to request to the other party to show me his ID. This is the protocol that I'm going to support. Okay. Also, when making TLS connections, if there is a TLS request in any other interface other than ETH0, you can also say, I want to use the same TLS, okay, with this version here. Okay, so this is kind of what is my default certificate if I get a request to establish an SSL connection in any other interface, other than ETH0. Okay, so that's what it is. So let me go back to the basic configuration section and certificates. And I told you that we have two sections here. One is called the private certificate, which is where we created a certificate. We created the ID card, the driver's license for this Ingate to use when identifying itself to another entity. Okay. Here you have another section that is called CA certificate. And in your case, it's going to be empty. It's going to be nothing there. And you want to leave it like that. But what is this used for? It's used for, let's say, for instance, we are connecting my telephones. Okay, so we are going to use TLS for connections to remote phones, and those phones are going to be Mytel. Any phone manufacturer that supports TLS, they have pre-built at factory certificates, and they have been signed by a certification authority that belongs to the vendor. So Mytel has his own authority to sign certificates, and they load a unique certificate to each one of the phones that they sell. So the certificate that the phone is going to send to the Ingate when it tries to connect is going to be signed by MyTel certification authority. If that is the case and you want to validate that is signed by a trusted authority, MyTel must provide you the root certificate of his certification authority. And once they provide you that certificate, you load that certificate here. And this certificate is the certificate of a certification authority that you want to trust from now on. So if anyone from the outside sends you a certificate that is signed by this authority, the Ingate will trust it. Okay? So any certification authority that you want to trust on the Ingate, you must find the root certificates for that certification authority and load them here. Okay, so we are not going to use this because we are going to use only self-signed certificate. And that's the reason why we are using the microchip soft phone, because the microchip soft phone doesn't validate certification authority. Otherwise, for the training, I may need trusted certificates on the Ingate, and then I have to pay for those certificates. I have to do that every single training. So that's a cost associated that we are not willing to incur right now. Okay, so well, once you have the certificate created and under the services you have enabled yes TLS protocol, selected the certificate, and then enable signaling encryption, associated the certificate to the interface, selected the protocol, defined the default. Once you have done that, you can just go and apply your changes. And now the Ingate is able to at least initiate a TLS connection with the phone. Now, if I want to test this, I'm going to need to, let me go to the phone. Where's my phone? My phone is here. Okay, so here is my microchip phone, okay? If I go to the extension, let's say that I'm using, for instance, this one, test, I'm sorry, test. And I want to enable TLS, I have to edit the configuration, okay? And you have all the information you already loaded, which is correctly. And now, here on the transport option, you're going to change from UDP to TLS. Okay, and once you do that, you save and check if you are able to register. If you are able to register, you did the configuration correctly. Okay. If you are not able to register, then something is wrong. Let me just do it on this one. I want to show you something. Let's do TLS. Oh, mine is not working. Do this one.
Mine is active.
Yours is active?
Yes, sir. Online.
Okay, you're gonna notice that now says online, the green button here, okay? And it has a little lock. Is that correct?
That is correct.
Okay, that shows you that the signaling has been established and is using encryption. Okay, once you have that with the lock, means that you are already connected using encryption. And you can test the call, or you can dial *43, etc., and it should work.
Just like you see in your browser when you go to your bank or various websites, you see the lock in the lower right.
That is correct. It's the same concept of going to an HTTPS website, okay? And when you go to an HTTPS website, for instance, if I go to Ingate. Let me see if it's Ingate the case. My website Ingate. Okay. It shows the log here. Okay. And this log, in some websites, it shows the log even in green. But if you go to a website that is using a self-signed certificate, like the Ingate, the lab Ingate that you have, if I use HTTPS for my Ingate, okay, you're gonna see this typical message saying not secure, okay, and you have to do advanced, etc. What it's saying here on HTTP, I mean, it's a total out of the SIP topic, but it works exactly the same way. The SSL certificate. When you go to a website and you have this message, it means that this website is using a certificate that has been signed by itself or by an authority that your computer doesn't trust. The trust certificate, the CA certificate for whoever signed the website certificate is not in your trusted list of authorities. And that's why this happens here. And that's why you can just click here and it's going to show you. Let me see if I can see the certificate. Okay. And I can see the certificate path and sees this CA root certificate is not trusted because it is not on the trusted root certification authorities store. It's telling you that you don't trust whoever signed that certificate. So in websites, it's up to you to decide to go to the website anyway. So that's why you click advance, you go here and you are saying, okay, I'm taking the risk and I'm going to the website. At the end of the day, what does it mean? It means that you don't trust whoever signed the certificate, but you know this website and you are willing to go because the certificate, the only thing the certificate does is to encrypt everything moving back and forth between the web server and your web browser. All the information that is going through the internet between your PC and the web server is going to be encrypted, okay? And you trust, you decided to trust, and you go to the website with HTTPS because let's say this is a bank and you are typing in your credit card numbers and things like that, and you are sure that all the information going back and forth between your PC and the web server is not going to be open to everyone to capture and read. Okay. Okay, so that was a diversion, but it was worth it to explain what I was trying to say. Okay, where is my group line? Okay, I'm here. Okay, so the exercise we need to do basically is to create a certificate and enable on the phones. I show how to do it on the microchip. Just enable TLS as a transport protocol. On the GS Wave, it's very similar. You go to the configuration of your extension, and you're gonna find some place near to the bottom of the configuration page, a place where you have transport protocol and it says UDP, and you have to change to TLS. So once you do that, then everything is gonna be TLS. So that has a few additional implications. For instance, if you are doing a pickup or capturing in the login here, and you enable packet capture, and you start capturing, okay, you're gonna notice that when you try to see the calls traffic on the pickup file, you are going to see just the leg inside your network, but you are going to see nothing related to SIP on the external side because it's encrypted. I mean, the signaling is not being able, there is no way to read and not even to identify that is SIP running there. Okay. So were you able to do the configuration? Is anyone having problems to register on TLS?
Where do you do it on the cell phone app?
On the cell phone app, well, it's not mandatory for the class, but if you want to have the two phones using TLS, yes, you're gonna need to do that. But for the SRTP, which is the next section of the lab, you may have some problems, and I'll show you what I mean by that if you want to call from one extension to the other one. So now just changing the microchip to TLS and keeping the GS wave on UDP, because you have not closed the UDP port here on the basic of settings, you still process UDP on 5060. So you are going to be able to call from one phone to the other, okay? And establish a call even one of the phones is talking TLS and the other phone is talking UDP. Okay, is that clear? Any other question?
No, I'm good.
Okay. Okay, next step is now we learn how to create a certificate for SSL. And up to this point, we have been talking about signaling, only signaling. When you talk about TLS, you are talking about SIP encrypted, SIP signaling protocol. You are not talking about media. The media is still open. The media is still non-encrypted. The media can still be tapped in the internet and recorded by a third party without you even noticing that it's happening. Okay, so we still have the media unprotected. So next section will be, let's encrypt the media then, okay? And you're gonna find under SIP services that the same way we had the tag for signaling encryption, we have a tag for media encryption, okay? And that tag for media encryption is actually disabled. So we are going to enable, because we want for the Ingate to be able to encrypt the media, okay? And then you are going to define the policies of how the media will be encrypted. In other words, is how I can say the media in this case is encrypted, or in this other case is not encrypted. So the way for the lab that we have designed this is, you have, first of all, a section that is called SIP Media Encryption Policies. And you can create here all your policies. And then just after that section, you have another one that says Default Encryption Policy. So the strategy I'm taking for this lab is, I will use the SIP Media Encryption Policy to explain when encryption is not needed. And then the default policy will be encryption is mandatory. So in other words, I'm just defining where encryption is needed by explaining where it is not needed, and anything else will be encrypted. For instance, remember that we have a network called Twilio, and we have included in that name not only the IP addresses for signaling, but also the IP addresses for media. So, and I know that the trunk that we provision for the labs are not provisioned for TLS, neither SRTP. So I need to make sure that any traffic going to Twilio or coming from Twilio will never be encrypted in terms of the media. Okay, so next to the media network, there is a column called suite requirements. And then if you pull down there, you're gonna see different options. And I'll explain that in the real system, okay? So I also know that the PBX will not need to be encrypted. So I'm going to select the PBX network to say the PBX will not be encrypted. Clear text has the suite. The encryption suite means non-encrypted. That's the meaning of clear text. Okay, and I know the LAN will not be encrypted. And then my default policy is everything else will be SRTP, meaning encrypted. And in all of the case, will allow transcoding. In other words, if I have a call, an inbound call coming from Twilio, okay, that call will land on the Ingate. And I know the media in that call is non-encrypted, okay? But if that media, if that call then goes to the PBX, and then from the PBX to the Ingate, and then from the Ingate to the remote extension, okay? So the Ingate from the remote extension will be encrypted. So the transcoding between encrypted and non-encrypted will be done automatically by the Ingate. The Ingate takes care of doing the transcoding between RTP encrypted and RTP non-encrypted. And that happens because we enable transcoding here on this column. Okay, so we're going to enable transcoding in all of them. Okay, so, and then once we do this and apply those changes, then you can go to the phone. Okay, and when you go to the edit account, just next to the transport TLS that you selected just before, okay, there is a just before there is media encryption here, okay, that by default is disabled. So you have two options, three options: disable, optional SRTP, or mandatory SRTP. And we are going to use mandatory SRTP. Okay? And once you do this and change this configuration, you should be able to still register and make phone calls. And in that case, the media will be encrypted. How you can see that on the phone, if I am not wrong, the same way the signaling shows a little lock on the online icon, the green online icon, when you make the call, if the call is encrypted, you're going to have some message when the call is active, some indication that shows that the media is being encrypted. And once the media is encrypted, no matter if anyone detects that it's an RTP session, even if they can tap it and record it, it's going to be just scrambled. You are not going to understand anything. It's just
So I see an error on that encryption for the TLS. I actually was able to add it on the phone, and I still have the icon, but there are two errors coming up under media encryption and sessions and media under SIP services.
Okay. That was Ed, right?
Yes.
Okay. Let's see exactly what is happening in your case.
Okay.
Yeah, let me just stop sharing here. Okay. Media encryption requires. Okay. Interesting. This may happen to everyone. Media encryption requires media proxy. Okay. And in this case, because your system is you are doing the configuration from scratch. Okay. When it says media encryption requires media proxy, means that in some place I need to enable the media proxy. Okay, so it is not here. I don't see anything here that relates to media proxy. Where is this media proxy stuff? Let me request your control. Okay. Okay. So I'm going back to. Okay, I'm on SIP services, and you see this section here called sessions and media. Okay, if I go to sessions and media, you're going to notice that the media proxy is disabled. So we need to enable the media proxy, okay? And you can keep everything else as is. Always use media proxy? No, it's going to be used when it's needed. So that's the only thing you need to enable. And once you do that, the error will disappear. And now you can go and apply your changes. And that's it. Okay, so if anyone has the same message, I just repeat what I said is, let me just share my screen and I'll show you in mine. Where is my, share my screen, screen 3. Okay, so where's my browser? Here. Okay, what I did, if you get that message saying that the media proxy is needed, then under same SIP services tag, there is a tag here called sessions and media. And in the sessions and media, you have to make sure you have the media proxy enabled. And once you have the media proxy enabled, that the error will disappear. That what it's saying is, well, the reason for the error is saying, okay, Mr. Engineer, you want for me to manage media, encrypt the media, and transcode the media. If you need for me to do that, I need to use the media proxy, which is a functionality inside Ingate. Okay, and the media proxy is disabled, so please enable the media proxy. So you go here and you enable, and that's it. You have to just apply that change. And once you do that, okay, you should be able to change the configuration of your phone and enable the media encryption here, make it mandatory, save it, and then you're still gonna have the online signal, but then you can test dialing, for instance, star 43 and see if the media goes through, and you can listen the other side, and you can speak and listen yourself with the echo server, etc. Okay, is anyone having troubles? Okay. Anyone falling behind?
No, I have them working on both my phones.
Okay, do you need help?
Good to go.
Looks good.
Okay, I'll give you a couple of minutes to finish the configuration. Okay, I am thinking about a few more questions that I can make you regarding the typical scenarios you're gonna have in real life, right? Most of your installations, most of your customers, even that is gonna be changing very rapidly on these times, is trunking. But more and more customers are starting to have remote users. And then remote users is a big security hole that you need to close. Then you're gonna need to enable TLS and SRTP and all this stuff. But in any case, same concepts of TLS and SRTP can apply on the trunking side. Okay, and I have seen customers, mainly financial institutions, that when they get a SIP trunk from the carriers, they require the carrier to provide a secure trunk. And some carriers such as AT&T and I think CenturyLink, at least as far as I know, that's an extra feature that you pay for if you want the trunk to be secure. using TLS. From the Ingate point of view or perspective, what you need to do is on the SIP trunk inside, okay, if I go to my SIP trunk, remember when you did the configuration for the trunk, you did not select any signal in transport, but if I select TLS here, okay, that's the only thing you need to do in order to enable TLS for the trunk. Everything else is already done with what we did because the certificate is already loaded. You created a certificate for TLS, and that's the certificate that is going to be used. Most likely, the cell sign certificate will not be accepted by the carrier. In that case, if you are going to start having TLS with third parties, like your service provider, you're going to need, instead of self-signing a certificate for TLS, you're going to need to create a certification signature request and then set it to GoDaddy or VeriSign or Let's Encrypt or whatever of those certification authorities to get it signed. And once you get it signed, you load it in the Ingate, and then the TLS with the carrier will work, should work. Okay, so that's one thing. And regarding SRTP or media encryption, is exactly what we did. Instead of here on the media encryption, mine is disabled now. Okay, on the media encryption, I didn't do the exercise here. On the media encryption, I was saying my LAN, my PBX, and Twilio, they are using, my LAN is on UDP, my PBX is in UDP, my Twilio is in UDP, and this is going to be clear text, clear text, clear text. All of them will be transcoded if needed, transcoded if needed, and my default will be SRTP, and transcoding will be allowed. This is the exercise as we are doing it right now, right? Okay, so if tomorrow I decide to move Twilio to TLS and SRTP, I have to enable TLS on the trunk, and then I can change here to SRTP for Twilio, or I can just delete it, because if I take Twilio out of this media encryption policy, the default policy will apply for Twilio. Okay. So those are the only two things that needs to be done just to enable SRTP also on the Twilio, on the SIP trunk side. Okay, any questions? All good?
I'm good.
Okay.
Oh, good.
Okay, one question you may have in your mind is, what's the difference when you do the configuration of the phone, okay, of the phone, let's say on this phone, okay, you see I told you to select mandatory SRTP. What's the difference between selecting mandatory or optional? Okay. The difference from the phone perspective is when the phone initiates a call or when the phone tries to answer a call, remember that on the signaling, all the media negotiation is happening as information that is interchanged between the two entities on the SDP section of the invite. Okay? So on the SDP section of the invite, you remember that I showed you one of the variables that is used on the SDP is one that is called the media record, the M. M equal, and I showed there that there was a way to identify this is going to be encrypted because it says RTP/AVP or SAVP. Okay, so when you select optional, the SDP negotiation, the SDP offer made by the phone will send two records, two media records, one with encryption and the other one without encryption, trying to tell to the other side, I support both. I can do encryption or not encryption for the media. Okay, and the other one can do the same. I mean, if I want the Ingate to offer both, okay, I can say, for instance, here in the media encryption, I can say, for instance, here, let me just keep this like this. Or let's say, for instance, that I want Twilio to be encrypted if necessary or not encrypted. So instead of selecting SRTP or clear text, which are the two ends of the same equation, clear text is non-encryption, SRTP is fully encrypted. Okay, if I select any transcodable, that includes clear text and any encryption. Okay, and how you know that? How I know that? Is because this table here at the end. All those names that you see on the pull-down menu here, those names here are described here. Any transcodable means clear text, SRTP with this cryptography, or SRTP with this other cryptography. Okay. Clear text means clear text. Encrypted transcription means SRTP with two different cryptography offers, and SRTP means SRTP with three different offers. So, and this can be modified. Okay. So, okay, I just wanted to explain, because one of the typical errors that I have seen in real customer cases is the calls. If one of the parties is saying mandatory and the other party says it's optional, sometimes the call is never established because one end doesn't allow to receive two records offer on the same SDP. And then you have to or decide to go clear text or decide to go full encryption, only mandatory. Anyway, so. Okay, so we have already added TLS and SRTP to our lab. You can test calls. I guess you already did some test calls. You can test calls inbound, outbound, the same test calls we did yesterday. Inbound, outbound to the PSTN between extensions, to the star 43, echo test, etc. No? Okay, now next steps will be adding additional security components. Okay. Somebody's testing, nice. Okay, next steps will add more security. I'm gonna give you about 10 minutes to finish if you have to finish something, or even to grab a Coke or something like that. I need to do a quick stop now, and I'll be back in 10 minutes. Is that okay?
Sure, works for me.
Okay.
It's fine, thank you.
Okay, 303, 313, I'll be back. Okay, I'm back. You had any issues, problems?
Yes, Ernesto, I'm sorry.
Go
I'm
ahead.
actually noticing on my cell phone extension 1712.
Mhm.
I actually have all the information. I'm looking in the account settings at the moment, editing account, and currently something's missing. I can't make an outbound call. I get a 404 error.
Okay, but you were able to find the
Yes,
transport
wait.
to
Yeah, I
enable.
have. Actually, wait a minute. Let me get back in there. Account settings. Actually, it looks live now. One moment. Let's try that. No, still a 404, not acceptable. 488, not acceptable.
Okay, 488 means transcoding issue. That's
Okay.
what 488 means. Let me stop sharing here. I'm gonna ask you to share your screen and show me the phone and also the Ingate.
Keep in mind, the PC phone is fine. It's my cell phone.
Oh, you're right. But the PC is fine. Let me double check something. Let me see if I can do something here. Let me see. Where's
It may be my SIP authentication ID.
yeah, hold on 1 second.
Sure.
I want to.
Okay.
Let me see what is the. There's 874. 874. Going to try. Yeah. Okay, I'm going to try. I'm sharing my. Let me just mute myself. Okay, this is the setup of the phone, right?
Yes, I'm in the account settings.
You see that one?
I'm actually showing a different type setup here.
Is your phone an iPhone or Android?
Android.
Yeah, that's the Android application. So you should have some place where it shows SRTP mode.
I do not have that. I have basic info, account name, SIP server, SIP user ID, SIP authentication ID, password, Vmail user ID, and display name. That's it.
Oh, but you are here in the edit account. Move back.
Yes, they're right there.
Move back
Back. Yes. Okay.
one step and then go down to the end.
Enable SRTP. Great. Okay, that's enabled.
SRTP mode.
Right, RC, the RFC 5168 you have off. Mine is on. I'm turning that off. Okay, SRTP mode is enabled. Enabled and forced. Okay.
That should be enabled and forced.
Yes. And let's see
And
if
your
that does it. Let's see if that does it. One more. Looks like it's doing it. It's attempting to call, but it's not going anywhere. Let's try that again. It's attempting to call, but it's going nowhere. Calling 1712.
and
One moment. Let's do this again. 1711.
okay. The two parameters that should be configured are TLS, the transmission protocol here, this one,
Let me get back in there.
should be TLS, and then at the bottom, SRTP mode should be enabled and forced.
Okay, TLS. Now let's try.
Is the phone getting registered?
Determine that yet. One moment. We're working now, yes. The other way. One moment.
Make sure that,
Yep, I am good to go.
okay, good.
Thank you, sir.
Okay, okay. Anyone else having problems? Let me just stop.
Yeah, I was able to dial it, now I can't for some reason. I'm rechecking everything.
So it's not working?
No, I'm getting an okay, I'm getting the lock. Yeah, I'm getting the online with the phone, I'm getting the lock.
Okay.
It's suddenly not letting me dial out.
And that is happening with the microchip or
Microchip.
okay, let me just stop here. Okay, can you show me?
You requesting a share or?
No, can you share? Let me just stop my phone. Yeah, I was struggling with my phone. Yeah, can you share your screen? Okay, so show me the phone. Let me request you. Request remote control. Okay. Okay, it's registering. And if you dial star 43, for instance. Okay, it gets a not acceptable, you see?
Yes.
Okay, so, and that is because, let me just double check the configuration. Edit account. Okay, it's because you selected optional. It has to be mandatory. Mandatory SRTP. If I save this, now I test star 43. Oh, still not acceptable. Then let me just check over here in your SIP services, media encryption. Oh, yes. No, this should be clear text, SRTP, transcoding. Let's see why it's saying.
Yeah.
There you go. Okay.
So what was
Okay.
it that on,
No, I guess the problem was, I mean, for the exercise, we need to make it mandatory, right? And, but I think the last changes you did were not applied. I saw that red label here on the top.
I saw that too. I made some,
Yeah,
but
maybe there was a pending change that fixed the problem, but you don't remember, nor either me remember exactly what did you change. But now it's
it worked too. So
yeah, yeah.
I actually got it to work without that colon 5061 transport equals TLS in the proxy. I got it to work even before I did that, which was strange.
Yeah. Well, it has to be an explanation. Anyway, so now it's nice working.
Thank you.
No problem. Anyone else? Okay, seems that everybody was able to, all of you were able to make it work. Okay, so you can play even later if you want. You can remember that we show how to generate pickups. So you can test calls and do the capture and then go to Wireshark and look at the files. And you're gonna see that you are not able to see any traffic on the external side. You're gonna see all the traffic between the Ingate and the PBX, but will not see any traffic between the SPC and the phones, because now you are hiding everything on the external side except for Twilio. Okay, and the reason we did the configuration using the explaining which ones are not encrypted is because if you say, for instance, all my external side internet connection from outside is going to be encrypted, then because Twilio is on the internet, it's going to be an overlap. And then you are saying that Twilio needs to be encrypted, and it's not. So that's why it's better to say Twilio is not encrypted, the PBX is not encrypted, the LAN is not encrypted, and everything else is encrypted. Then you're gonna cover all the rest of any IP destinations on the internet has encrypted for the media. Okay. Well, if we don't have questions, I want to move forward. And the next section is dedicated to how to configure additional rules in order to detect and prevent potential attacks. Okay, is what we call intrusion detection and intrusion prevention. Okay, there is a under the SIP traffic tag, there is a specific tag called IDS IPS. Okay, by default, it's usually disabled, and you can just enable that. And I'm going to go into the real live system and explain the details of all this page. So let me go to the real system. Okay, so under SIP traffic, we have the IDS IPS section here. Okay, and usually by
Not
default.
seeing your screen, buddy.
Oh, same mistake. I always make the same mistake. Thank you for telling me.
You're welcome.
Okay, so if you go to the SIP traffic, you're going to see a tag that is called IDS IPS. Usually by default is disabled. You can just enable that. I'm going to explain all these different fields or tables. The first one is one that is called packet match definition. And the purpose of this table is just to define criteria to match packets. The reason why you want to match a packet is it will depend. It could be for blocking those match or maybe to allow those matches. Okay. So for instance, I just created, by default, you're going to see that when you enable the IDS IPS, is already one rule already added to the packet match definition, which is the one called scanners. Okay, and scanners, what the SIP community understand as a scanner is a user agent that is trying to scan which IP addresses are able to respond to SIP requests. Okay, and the way the community detects them is by looking at one of their SIP headers, which is the user agent, and look on what it says on the user agent, and they have been recognized. Okay, and this information that is public and usually change over the time. Okay, but it's well known that any SIP request or transaction that arrives to you in Gate, which user agent is PP or contains, for instance, PPL SIP, people SIP, or friendly scanner, or Sunday DDR, or SIP vicious, or, and there are many names that are known they are scanners. So there is a rule that is already built in that already have um, the way of detecting those known scanners. The way this works is you can match by different criteria any SIP packet arriving to the Ingate. One of the elements for matching is the network. You may say, for instance, let me just explain the scanners one, and I'm going to use it as an example of how this is matching. So I'm saying on this scanner rule, I'm saying if the SIP packet is coming from the one, I may say if the SIP packet is coming from known source or LAN or Twilio or PBX, any name of the names that we created at the beginning, okay? You can also match by transport, saying, in this case, I'm saying, I don't care about the transport, any transport is fine, but you can narrow that to TCP or UDP only. Then you can look at the message and you can filter or match for specific requests or for responses. Or if you don't select anything, then you are not paying any attention to the type of message. In this case, it's using request. Remember the difference between a request and a response? Okay, and then if it is a request, I'm going to look into different elements of the request. It could be look at the start line, or look at the method, or look at the request URI, or look at the headers, or look at the body. So in this case, it's looking at the headers, okay? And then it's going to use this expression here as a regular expression. And using regular expressions, we'll try to match. For instance, it's going to look at the headers and we'll look for the user agent header. So it's going to matching user agent column and then a regular expression. And the regular expression says dot star, meaning user agent followed by anything that contains, and I use parentheses here, and you see the pipe character here. There's a pipe here, there's a pipe here, there's another pipe here. The pipe means or. So I'm saying, what I'm saying on this expression is, if the header match the name user agent colon, and then after the colon comes anything that includes PPL SIP or friendly scanner or Sunday DDR or SIP Vicious or SIP CLI, and after that anything else, okay, is going to match. So I'm scanning, I'm filtering any request, looking at the headers coming from the one which user agent is one of those, or SIM one of those. Okay, that's an example. Okay, and this one, the scanner is already included on the default packet match definition records. I'm adding an additional one here that you can test it if you want. I call it roaming users. I'm trying to find a way to match all the users that that you have configured for the labs. So I know those users, those extensions are microSIP based or GSWave based. And I know for sure that the user agent field, the user agent header, must have the word microSIP or the word grand stream as part of the user agent. So I want to match them. So any transaction coming for any of your extensions will have inside the user agent field one of those two words, microSIP or grand stream. Okay. I'm not saying yet why I'm matching them, but I may use that to allow the traffic from them. I created another one that is called known, okay, just to match any traffic coming from known sources. And the only thing I'm matching is the network, because the known sources is the name of the network that I created. If you remember in our examples, this is a known source, and I put under known sources my LAN, my PBX, and Twilio. Okay, so going back to IDS IPS, I created that rule here. So at this point, I'm not saying what I'm going to do with these matching rules, but I just created them. I'm not going to talk about packet rate thresholds yet. Let me just move forward with this section here that is called the packet filter rules. Now, in this packet filter rules table, I can take decisions on what to do with the matching rules that I just created. For instance, the rule number one, and in this case, on this table, the order of these rules, order by number, has a meaning, because that's the sequence the rules will be applied. It's going to try first check if the traffic is matching the scanner rule. You see the matching rule. You can just pull down and select which matching rule I'm going to use. I'm saying, for instance, if I have a packet that is matching the scanner's rule, I call it scanners, but I could call anything else. I'm going to discard that packet. Okay, so that's my decision. Any scanner will be discarded. I created another rule that I call it let it go, which means that if I know the traffic is coming from a known network, I will allow that traffic. Okay. Then I have another rule that says roaming users. Okay. And I'm going to say, and this rule is, if the roaming users match, okay, I'm going to allow the traffic. And I created a very last one rule saying anything else. matching nothing. I'm not going to match anything here. I'm just going to discard that traffic. So any calls, any requests that match the scanner will be discarded. Known and roaming users will be allowed, and anything else will be discarded. Okay, and that's the order that they will be evaluated. So I cannot put, for instance, this one has the first one. If I put anything else has the first one, so then any traffic will be discarded. So you want to block everything. Okay, so this is an example that you can test it and implement it. And okay, now I'm going to explain what is the packet rate threshold. That's a different type of a blockage. Okay, so again, go back. Packet match definitions allows you to create matching rules, and then you decide how you want to use them. Those matching rules can be used in two different ways. One is using the packet filter rules. You take decisions of discarding, rejecting, or allowing. Okay. The difference between discard and reject is that discard simply doesn't pay attention to the packet. It's not doesn't pay any attention. Don't do anything. If you select reject, the packet will not be accepted, but will be responded with a rejection reason. It's going to send a 403, for instance. Okay, so that's the difference between this. I do prefer always to use discard instead of reject, because it's better for the other side, the attacker, to think that there is nothing responding there. That is something, even I was not able to get the invite across and get the invite processed, I know that there is something there that is responding to SIP traffic. So I always prefer to do the discard. So and the second thing you can do with those matching is packet threshold. And the packet threshold is something to allow you to measure what is the rate of packets happening coming from a specific IP address. For instance, let me just, the other thing that I forgot is any of those rules can be enabled or disabled. You don't need to delete a rule that you don't want to apply for a certain, in a certain moment, okay? You can just say, I'm not going to apply this rule. You can make it active, or you can just make it inactive just by saying no here. Okay, so the packet thresholds, all of them are disabled, are non-active, okay? But let me explain the second one, for instance. If I enable this one, I'm saying I'm not going to match any matching rule, okay? But I'm saying here that I'm going to be evaluating time frames of 10 seconds, okay? And if the number of hits I'm getting from the same IP address is equal or greater than 500, I'm going to blacklist that IP address for 300 seconds. So this is going to prevent flooding. The typical flooding attack is a denial of service attack. So somebody's sending invites or SIP options or whatever transaction from the same IP address, and they start to push a high rate injection of that specific transaction. So if you get a high rate, you're going to block it. You're going to blacklist that IP address. Okay, and you can you can decide for how long you're going to blacklist it. If you say 300 seconds, after 300 seconds, the blacklist, the IP address that you blocked will disappear from the blacklist, and then they may be the case they're going to start, injecting traffic again. The number you can put here can be as higher as you want. I can say 999,000 seconds, and that's going to be almost forever. Or you can do small periods of time. You have to be careful on using the thresholds. Let me give you an example of why. Let's say you have branch offices, okay? You have a headquarter and data center where all your telephone infrastructure is located, and you have branch offices connected through the internet or through whatever IP transport to the corporate, and the extensions are just registered into the corporate PBX via the Ingate, for instance. And let's say that one of those branch offices is a building that has about 1,000 extensions, okay? And let's say that they have a power outage in that building. You know, the power went out, okay? So no power on the building, and after a while the power comes back, and everything turns on. Okay, so including the phones, all the phones will boot up again and start trying to register. So can you imagine 1,000 extensions sending the registrar attempts trying to register into the corporate? And all of them are sitting behind a NAT, behind a firewall. So from the Ingate perspective, there is a bunch of transactions, same type of transactions coming, all of them from the same IP. You may trap them here without really wanting to trap them. And you may be blacklisting them with a false positive detection. You think it's an attack, and it is not. It happens to be a high rate of registrations at the same time coming from the same IP address because they had the power out for a few minutes, then come back, and everybody was trying to register at the same time. Okay, so that's why maybe you can apply this to, you can create some type of a network criteria that includes any IP address that is not part of my known IP address, known sources. For instance, I can create, let's say, just let me give an example. I'm going to create another rule that is called unknown. Okay, and I'm going to select here known sources. Okay, and the only difference between this rule and this rule, the known and unknown, is that I'm going to tag this field that is called negation. Okay, if I tag this negation as unknown, this negates this match. So what I'm saying here is this is going to match when the IP addresses doesn't belong to the known source, because I'm doing the negation of the matching rule. And then I can say that this rate is going to be applied only to the unknown IPs. Then I'm taking out all my branch offices from that rule of high rate blockage. Okay. So the only thing I want for you to do in terms of the exercise here is to add the roaming users rule, put the regular expressions to match your two extensions, the microsip and the grand stream, and enable activate the scanners. You're going to add the rule also for the known IPs, the known sources. And then you're going to do this, block any scanner, discard any scanner, let it go or allow any known source, allow any roaming users, and block anything else. And once you do that and apply these changes, see if your phones still register. Okay. You can also play with it. You can change here and say for roaming users, discard them instead of allowing them, and test if you are able to register the phones. Okay, so if you test that, you are testing that the rule is working. Okay. I'm going to leave this screen here. Any questions?
Yes, it appears that the soft phone on the PC is no longer registered, but the cell phone is registered.
Okay. And what you did, you added these roaming users and so on?
Yes, I have all of that. The only one that I didn't add is that number one that you have up there, the known with the known source.
Okay, let me take your case to illustrate to everyone what is happening.
Okay.
Okay, let me just stop sharing here and allow me to access your unit. Okay, so you added the known sources as Twilio. Okay, and the roaming users has one. And the header user agent. Okay, okay. It looks okay. You are going to discard the scanners, allow, let it go, and then let me just request the control. Okay, so I'm going to take this case just to also practice all the troubleshooting tools. Okay, so I know that my microchip is not able to register. Even it seems to me that we did the things correctly, right? So if that is the case, let me go to login. Can you put your password there?
Yes.
Okay, I'm going to log in, and I know I'm having problems to register my microchip. So I'm going to filter just register transactions here. Okay, and show newest at top, SIP records, blah, blah, blah. And I'm going to show, everything. So let me just try to display log. Okay. You see the beauty of this? You are already blocking others. Is somebody trying to register with the extension number 9603? You see here? And you see that your packet is filtering them out. And it's coming from this IP address. Okay, Control F. Let me just look for register SIP G08. Okay, so this is the G08. Okay, let me see why it's not registering. That's your extension 17.1.1, right?
That's correct, yes.
Okay, so I get here, register 1.1, received, I send. Okay, so you see what is happening here? When we send, I'll show you. Let me see, what is the register, the initial register to that connection here. Okay, this is the first register. Okay, we send the register to the PBX correctly. Okay, and the PBX responds with a 401. Okay, unauthorized, which is what I expected, right? The PBX is telling me, okay, send me your credentials. When you do a registrar and you send the register transaction to the PBX will challenge back with the 401 saying, send me your credentials. And that's what the PBX is doing. Okay, but this 401 coming from the PBX is being blocked by the anything else rule, okay? Because the anything else rules, this transaction 401 unauthorized, okay, is interpreted as an attack. So the 401 will never reach back the phone, and the phone we're going to keep sending initial registrar attempts, and it's going to stay there forever. Okay, so your blockage rules is blocking the responses from the PBX. So let me go back then to the IDS IPS. IDS IPS. And then, okay. Let's change this to request. Agent. If the header is microsip. Coming from the one. Okay, so this is what I'm going to do to fix this problem. I'm going to create here a matching rule. Oh, knowing sources. Yeah, the problem is happening because this 401 that is being rejected should be authorized
PBX.
on the knowing source, right? But it's not being authorized or it's not being matched with the known source because your known source is only Twilio. So let me just, to fix that problem, I'm going to create here a network name called known sources, okay? And I'm going to add here my Twilio, my PBX, and my LAN, okay? My LAN is coming from the inside. Oh, I don't need to do that here because it's already defined on each one of them. Okay, so I'm going to define the known sources and now going to the SIP traffic, IDS IPS, and my known sources now will be known sources. Okay, and now the rejection for the 401 response will not happen. Shouldn't happen. Okay, so let's see if I'm telling the truth. Okay, let me see if I can just. Okay, you got it?
Yep.
Okay. So everyone understood what was happening. He was saying, okay, known sources, I want to allow the traffic from known sources. But he said known sources is Twilio. But in reality, it should be Twilio, my PBX, any traffic coming from my LAN, etc. But he didn't have a name assigned to this group of networks like Twilio plus PBX plus my LAN. So I created that name in my network names, and then I just modify on the rule he was pretending to use for known sources, and I selected known sources instead of only Twilio. Now the traffic coming from the PBX will not be rejected. Okay? Okay. Any other case?
Yeah, mine's screwed up, but I'll have to log out so we can see mine. I had it, my phone was registered, I just added the known sources, and now my phone isn't registered.
You're going just the other way in reverse.
Yeah, I went backwards.
Yeah, backwards. Correct. Do you want for me to take a look to it?
Yeah, I'll log out here and I'll bring it up so that I can share it with you.
Yeah.
Yeah, I think I'm having that same issue. I'm gonna watch you do his.
Okay.
Here comes my screen.
Okay. Let me just.
So I was in. I added known users.
Okay, you added known users, but you are saying that all the one is are known users, which is it should be known users. Okay.
Known sources, right?
Known sources, correct. As far as known sources, let me go to the network, and then you create known sources. Correct. It's my LAM plus PBX plus Twilio. That is correct. So IDS IPS. Okay, on the roaming users, you want to identify from the LAN, having on the request header user agent equal to microsip or ground stream. That is correct. Scanners are on the one side, request header using any of the friendly names, known, blah, blah. And known sources, I don't need these known sources here. I think this one is, okay. Maybe this was correct. And the other one you were using here, known users, is the one that was not necessary. Okay, so this one, let me take this one out. Okay, so now here you said let it go, known sources, and then anything else will be rejected. So let's see the flow of the logics here. We are saying,
And my phone did come back online as soon as you did that.
okay, so what we are saying here, the logic flows like, if it is a scanner, I'm going to discard. If it is a roaming user, okay, roaming user, I'm going to allow. If it is a known source, I'm going to allow. And if it is anything else, I'm going to reject. Okay, so now let me just apply these changes. And then your phone should be able to register.
Yeah, it is registered. The problem I was having is I wasn't able to dial anything.
Okay.
So I tried to fix it.
Mhm.
But now it seems to work.
Yeah. Okay. So I don't know if you noticed on the previous log review, let me just take a look to this one here. I'm going to see all the traffic. Let me see all the SIP traffic, just plain. And I want to show you why it's important to do this type of things, right? Like using the IDS IPS. Once you are connected to the internet, you are going to get attacked. I mean, there is no way you are not going to get attacks. That is for sure. You see here, for instance, this is an attack. No, this is not an attack. Let me see. Options, add request. Options. This, receive it from. This is okay. This is okay. Register. Okay, here. Okay, you see this one? This is an attack. Is somebody from this public IP address is sending you a registrar. Okay. Registrar. Extension 1238. It says it's an Avaya phone. Okay. Nobody's using Avaya here.
No,
Okay. But we are responding with a 403 forbidden. Okay. We are already blocking them. Another forbidden. But in any case, I will see. Let me show you something else that you can also do to illustrate. Here, I'm going to filter. Let me select none. I'm going to filter to see only SIP IDs. Okay, so I'm going to filter to only SIP IDs. Then, oh, no one. Okay, you see how many transactions have been rejected?
yeah,
All of them are attacks. Okay, so you can see, and also the other thing important to see here now on the traffic, SIP traffic status. Okay, you can see on the status. Okay, you have detected at this point 3 roaming users, 243 let it go. Those are approved to go, but anything else, 576, those are attackers. Okay. So as far, I mean, once you open to the internet, you're gonna start getting attacks. That's a fact, 100% sure that happened. So that's why it's important to implement something like IDS IPS. Okay, and the problem is that could take you to a fraud, because if they detect that you are open and they find a way to register an extension to your PBX, they can start making calls.
This vote, everything you say will be repeated back to you. That's as soon as it is received.
Okay. Any other case that I should take care of? Everyone good?
Yes, sir.
Okay. So let's move on then. Let me see, where's my slide? Okay, so you have a better idea of what is the IDS IPS and how it works. I didn't mention that there is an option here at the end. When you use the IDS IPS, there is one more section here that is called SIP system limits. Okay, one of the problems when you are having attacks.
We can't see your screen.
See your screen.
We can't see your screen.
Oh,
We're looking at you.
again. They're looking to me and you don't like me. So, okay.
I didn't say that.
No, I did. Okay, now, right? Okay, thank you for letting me know. Okay, so there is a section here at the end of the IDS IPS that is called SIP system limits. Okay, so when you have attacks from the outside, and one of the typical attacks that may happen is flooding, or what is called also is known as DOS attacks, DDoS, or the dynamic denial of service attack. In denial of service attack, the the reason why it's called that name is because the purpose of the attacker is not to commit a fraud, it's just to shut down your service. So if you have a SIP proxy or a PBX that is processing SIP requests, and you flood with, let's say, 1,000 of invites per second, okay, the SIP processing is going to get exhaust. I mean, it's going to get blocked at a certain point that there is not enough horsepower to process that load of requests. If that happens, the systems normally they crash. Systems very, very well designed, they may detect that problem, but they never crash. They expect to slow down the attack. Once the attack slows down, they go back to normal. So this is what this parameter is exists for. Is you can put a kind of a cap saying if my SIP system load goes above 80% of usage, just stop processing SIP packets. That is what it's going to do. The system don't crash. The system just stop processing SIP packets. That is going to affect not only the packets that are being used to attack, but also, of course, the normal packets. But the normal packets are already having problems because the system doesn't have enough resources. So once he stops processing SIP, most likely what is going to happen with the attacker is that the attacker is going to slow down. They're going to stop. So once the load goes down below 80%, the Ingate starts again the SIP processing. So it recovers itself because the attack went away. So if you don't capture those packet rates on these packet thresholds, okay, for any reason you don't trap them here, and you blacklist those IP addresses, you still have an additional measure here to limit to a certain level the maximum load permitted to the system to process SIP packets. Okay. Okay, let's talk about SIP filtering. Okay, and again, we are under the same security topic. We already use SIP filtering at the beginning. Okay, so as part of the traffic is just the second section here. On filtering, you didn't put any rule here for the filtering. You just said, I'm going to process all. Okay, but you can limit to process only SIP traffic from certain networks. I can say, for instance, I will process traffic from my known sources, okay, and I will process all. What we have here? Known sources, Twilio. Okay, so if I do this, I'm going to block also my remote users right now, okay, because the one, if I do process all for my known sources and reject all for anything else. If I do this, your remote phones will stop working because they are not under the known sources name. They are not because they are roaming users. But let's say, for instance, that instead of that we know the IP address, the public IP address, the static public IP address of each one of you guys at home. I can add the remote offices as a list of IP addresses, okay, and make them part of the known sources, and then anything else that is not coming from your home or your home office uh, will not be blocked, will be processed. In other words, if I say here, for instance, let me go to networks, and I'm going to create here a name that is called my office. Okay. My office, in my case, let me see, what is my IP? Okay, this is my public IP address. And then I go to I'm going to add this IP address here. Is on the external side. Okay, and now I'm going to add to my known sources, I'm going to add my office. Now my office belongs to the known sources. Then I can go to the filtering and say, I will process all traffic from known sources and reject everything else. And now I know that the traffic coming from my office, I mean my extensions, will work without any problem. But if somebody else is trying to register a phone or is trying to make a phone call from my neighbor's house, he has a different public IP address, he won't be able to do that because it's not part of my known sources. Okay, I don't know if I illustrated correctly, if you understood what I meant. Okay, but the only thing is I'm taking advantage of this known sources name, and whatever IP known IP address has a known source, I just add them here. So if you test something like this and you add your public IP address, that should work. But for instance, if your cell phone is using your Wi-Fi at home, then your cell phone will be able to register. But if you turn off the Wi-Fi on the cell phone and then try to go through the AT&T or whoever your carrier is data network, it won't be able to register because you don't know the IP address that is going to be using. And if you roam and you start moving from one place to the other, that IP address may change. So this is useful as far as the IP address of the remote offices are known IP addresses and are static. But when you have dynamic IP addresses in the offices, and also you have users using soft phones in cell phones and they are roaming around, then this is not going to be a good practice because you're going to block them. Okay. Any questions so far? Okay, let me just move to. Okay, this is the example of remote offices that I was talking about. Okay, and the last but not least component of security is what is called the brute force blocking. And the brute force blocking, what it's trying to do is, if you have an attacker that is trying to register or send a call, okay, and is being rejected because he's not sending credentials, let's say the PBX, every time an invite comes from the remote phone, okay, that invite is forward to the PBX and the PBX processes. If the PBX needs to authenticate the user, the PBX is going to respond with a 401 saying, I need to know who you are, please send me your credentials. And then the phone is going to respond, sending the right credentials, and then the call will go through. Okay. But when you have an attacker that is trying to flood you with invites or registration, any type of transaction that needs an authentication, okay, you can control that after a number of rejections, because credentials are not being sent correctly, you just block that IP address. And that is what the brute force blocking or prevention is. And this goes into the traffic authentication. Under traffic authentication, you have a section here that is called brute force authentication protection.
Before you get too far, Ernesto, the PC soft phone actually now is showing incorrect password. It just popped up on its own while we were looking at filtering.
Okay, did you make a change now?
I did make a change in filtering, and I'll get back over there. Under filtering, I have the one known sources under sender IP filter rules, process all, and then reject all.
Okay, so here on your SIP traffic, on the filtering, you added known sources, right?
Just like you have it there.
Okay, so who is in your known sources? Go to your network and review who your known sources is.
Sources are my LAN, my Twilio, PBX, my Twilio.
Okay, so, but your phone is now trying to register from your house, right?
That would be correct, so yes.
And your house has an IP address. And that IP address is not part of your LAN, it's not part of your PBX, and it's part of Twilio. So that's why it's being rejected. So you need to discover what is your public IP address at home.
Right.
If you discover the IP address at home, then you can create, let's say, as I did here, I created a name called my office and I put my public IP address. And then I added to my known sources, I added my office. And once,
right now, one moment.
hmm? Did you follow me?
Yes.
So once you add your public IP address at home as part of your known sources, that rule should allow the phone to register.
And now it says there's a loop. A loop was detected. I'm going to let you back in.
You're still having issues?
Yes, I'll let you back in. Take a look. It won't let me add the name. I actually,
Yeah, go ahead. Share your screen. Everybody learns. That's good for everyone. Share your, let me stop sharing.
yeah, I wanted to add my office or my home, and all I had there was choice of a lot of these.
No. Okay, let me. Okay, this is fine if you want to do it this way. Okay, let me just save this. Okay, let me just ask you for remote control. Okay, if you save this. Okay, now it's added. Okay, so now you have known sources includes your public IP address here. Okay, but just has a good practice recommendation. Okay, instead of putting the IP address here, because later on you may not remember what this IP address is, right? So what I usually do is I create, let's say, I create a role and I call it my office. or branch offices or whatever you want. Okay, and I'm going to put this IP address here. Now it's going to be easy for me to remember. This IP address is my office. Okay, I'm going to save this. And now, under known sources, I'm going to select my office. Okay. You see, my office is here. This is the IP address. And now I added my office as part of the known sources. Okay. So I have not applied these changes yet, but now on your SIP's traffic filters, you are saying any known source I'm going to process all, and anything else I'm going to reject all. Your phone should be failing, still failing. Okay. It's still failing because I have not applied yet these changes. So if I make active, I still have the same problem. So, but now, if I come here and I apply these changes, and now I'm going to the phone, if I am not wrong, I should be able to register. No? Okay.
Right.
What is this? No, this is wrong.
I updated my password.
You updated your password where?
Previously, this was already updated. This
No,
phone
no, this phone could not use another password of the one that I provided you because the password is on the PBX.
Okay, keep in mind, this soft phone was in fact working. Here's your password. One moment.
No, that's the password. This is the password to access the GUI interface of the Ingate. No, this is not the password.
No?
The password is this one here. Look at here, extension password.
Gotcha.
Yeah,
Right.
extension number followed by 1NG43.
OT.
Three. Yeah.
All right. Well, that's quite strange because that password was, in fact, what I changed it to. The phone had been working up to this point with the change of password.
That's weird.
Yes. Okay.
Anyway.
So I will take this out of here then.
No, that's fine. I mean, this is the password you're using to access the GUI. I'm pretty sure that's what you did, right?
Yes, that is correct.
Okay.
The Ibanez 505. Yes, that's my goal.
Okay.
Okay. Thank you.
Okay. That's curious. Ibanez is the last name of my uncle.
Yeah. I'm a guitar man. I'm a bass man.
Okay. So any other issues or falling behind? I think today we wanna end early. You have been going very quickly. Sometimes the exercises takes longer. It means that we have a savvy team. Very well.
Yeah, at least we think we are.
Yeah, I'm confirming that. I can confirm that.
If we don't make mistakes, how are we going to learn?
Yeah. Okay, let me just go back to. Okay, so I was explaining this brute force stuff. So let me explain what the brute force prevents then, how you use these parameters here. What this is going to do is the Ingate is going to validate for any transaction that needs authentication, either invites or even registrar when the PBX challenge sending a 401 or 407 requesting to the other end, please send me your credentials to process a call or to register an extension. It start counting how many attempts are happening with failure on the credential. If they happen one after other, and a specific number of times continuous failing, I can block that IP address, because I mean, if the extension is sending the credentials 3 times in 2 seconds, and the 3 times has been wrong, I'm going to block that IP address, because most likely it's going to be somebody trying to trick me. Okay, so here, this is what you control here. You say, for instance, if I say 3 here, meaning maximum amount of attempts. If I get 3 attempts of authentications in, let's say, 2 seconds, okay, I'm going to stop responding to that IP address for 3,600 seconds. Okay. So if somebody's trying to register a phone and 3 times continuously fail on the credentials in a time frame of 2 seconds, I'm going to block that IP address for 10 minutes, 3,600 seconds. That's what this rule does here. Okay. This other field, number of clients, is because the Ingate is counting based on the IP address that is originating the authentication attempt. I need to create a table. Okay, and once I get the first registrar with credentials, I put that IP address on a table. I mean, when I say I mean the SBC. The SBC puts that IP address on a table, and it waits for 2 seconds to see how many more times it fails. But if 2 seconds go through and it was no more attempts, or the next attempt was successful, then I take that IP address out of the table. So that table needs to have a size. And here you control what is the size of the table that I want to manage. So it's going to be, for instance, in this case, 128. You're going to be 128 active at the same time IP addresses trying to authenticate that I'm getting track of to check if they are failing more than 3 times in 2 seconds. That's what this number is. Okay, so we don't need to do anything for the lab in that case. It's one of those rules that you also need to be careful on, for instance, branch offices that has many, a huge number of phones trying to register at the same time because it was a power outage, and all of them will try to register at the same time. And if there is any failure for any reason, but it's replicated as many times as extensions, all of them are using the same IP address because they are behind that. And then you may be blocking the branch office IP address without any reason to block them. But in any case, also, if you have an attacker that is sitting behind a firewall of one of your branch offices, then the attacker may be real, but the public IP address that is being taken in account on the Ingate is the public IP address, and you have real users behind that IP address. So if the IP address is shut down because this rule, everybody's going to be shut down in that office. Okay. Okay, so we are almost done today. We are very quick. Do you have any additional questions today?
No, I'm good.
Okay, so next class is going to be short also because I mean we're moving very quickly. This is a good team. Don't forget to take advantage of me if you want to address any other topic or anything else. We're gonna have additional time also on Monday. Um, Monday is gonna be dedicated to how to use the Ingate as a firewall, and we're gonna enable the firewall mode, and we're gonna have a quick exercise on using the Ingate to as a firewall with port forwarding, and you're gonna be able through your Engage to access the PBX interface.
Excuse
And
me, Monday or Tuesday. I'm sorry.
go ahead.
Monday or Tuesday? I believe it was scheduled for Tuesday.
Oh, maybe you're right. Let me double check. Originally, it was for Tuesday.
Originally, yes, but that was changed to Monday.
Yeah, but I mean, I don't have any problem if you want to change that to Tuesday or Monday. What is the best best?
Monday for me, based on scheduling, had already been readjusted for that.
Okay,
Yeah,
so
it'd have to be Monday for me.
okay, so yeah, we did the change after a while. I mean, it was just on the second invitation. It was already sent for Monday. Is that a problem for you, Howie?
Monday.
Pardon me?
It has to be Tuesday for me.
It has to be Tuesday for you. Okay, so if everyone else is on Monday, what I can do for you, Howie, is I can have a session for you only on Tuesday.
All right, let me
That-
check with dispatch and see if they can move things around, but it might be too late for that.
okay, if you cannot move it, then don't worry about that. I'm gonna dedicate the time for you on Tuesday.
Okay,
Okay.
good.
Okay, so see you guys on Monday. Howie, just send me an email if you cannot. Well, I'm gonna notice you are not on Monday class anyway. Also, remember that all the systems will be up all the weekend. So if you want to redo some exercise, test something, do some whatever you want to do, and play with it. So they are 24 hours up up and running. So you can use them if you want.
Okay.
Appreciate it. You enjoy your weekend.
Okay, you too, guys.
Thank you.
Bye.
Okay, thanks a lot. Have a good one.